Earth, a unique planet, restless and dynamic. Continents shift and clash. Volcanoes erupt. Glaciers grow and recede. Titanic forces that are constantly at work, leaving a trail of geological mysteries behind. This episode travels back in time to investigate the greatest geological mystery of all, the birth of the Earth. Scientists explore how our planet first formed from the dust of the solar system, how molten rock solidified to land, how our oceans filled with water, and how life arrived on Earth. These are the earliest chapters in the incredible story of how the Earth was made. When it comes to finding clues to the birth of the Earth, our planet has been good at covering its tracks. Billions of years of erosion, volcanic activity, and the shifting of continents and oceans have destroyed almost all the evidence of the earliest stages in Earth's formation. For geologists trying to discover how and when the Earth first formed, this is a major challenge.
As geologists began to question the age of the Earth, and of course they looked for older and older rocks, what we began to find was that the further back you go in Earth history, the harder it is to find any of those rocks.
The search for the oldest rocks on Earth brings investigators to the harsh desert landscape of northern Arizona. This giant hole in the ground is Meteor Crater, formed when a massive meteorite slammed into the Earth.
We didn't really have rocks from the very beginning. Well, where could we find something? What about the meteorites that have been out in space and fall on the Earth?
It was here that geologists made a vital discovery. Meteorites are older than any rocks on Earth. They had found the key that would unlock the secret of Earth's formation. If the oldest rocks came from space, that is where the investigation must begin, in space. Our solar system, 4.5 billion years ago. At its center, the young sun.
The theory that emerged was that the sun was surrounded by a cloud of dust and gas, and as that cloud cooled, little grains of minerals formed. So all these little grains of minerals floating in this gaseous cloud are moving around the sun, and they start to bump into each other.
But there was a problem with this theory. Nobody could explain how colliding microscopic mineral grains could ever create an object the size of a planet. Then, in 2003, an experiment on board the International Space Station accidentally provided extraordinary new evidence. Astronaut Don Pettit wanted to see what happened to different substances in the zero-gravity conditions of space. He did a simple experiment by pouring some salt into a plastic bag and shaking it. The results were astounding. The particles immediately began to stick to each other, forming little clumps, all held together by tiny static electric charges. Scientists realized that if grains of salt stuck together in space, then so could the mineral grains in the solar dust cloud. Here was real evidence for the fundamental mechanism that kick-started the formation of the Earth. As mineral grains in the solar dust cloud bumped into each other and stuck together, they grew into small pieces of rock orbiting the sun. Over the next few million years, some of them collided and grew bigger. Many of these rocks are still orbiting the sun today. They have drifted for the past 4.5 billion years, unchanged from when they first formed. Occasionally, they fall to Earth, and we call them meteorites. They provide scientists with an incredible window onto the past.
We brought what's called a stony type of meteorite. What the scientists do then is slice across it and look on the inside. And to a planetary mineralogist, you start seeing all kinds of wonderful things.
This meteorite contains minerals and metals from every part of the solar dust cloud.
So what we're looking at is the assemblage of all these little ancient materials that were floating around the sun in the nebula of dust and gas. And when they hit each other, they gradually aggregated into solid bodies, which got bigger and bigger.
Gradually, billions of these rocks grew as they orbited the sun. First to the size of boulders, then as big as houses. And they kept on growing. When an object reached about half a mile across, its own gravitational pull became strong enough to draw other objects towards it.
Some object in this huge number of objects going around the sun, one of them had to be the biggest. And as soon as it gets bigger than the others, it's sweeping up more objects, just like you're driving through a cloud of mosquitoes at night in your car and the front windshield's getting hit more often. So the bigger it is, the faster it grows. And the faster it grows, the more gravity it gets, and that pulls in more objects. So the biggest object starts to run away from the crowd. It starts to grow fastest.
And that biggest object was the fledgling Earth. Soon, the young planet had so much gravitational pull that it began to attract bigger and bigger objects. As they crashed onto its surface, Earth's size increased with every impact. The bombardment was so intense that it only took about 30 million years for the planet to grow to almost its present size. The young Earth was made of billions of pieces of rock randomly stuck together. But geologists know that the modern Earth is not like that. Below the surface, Earth is separated into distinct layers. A thin crust, then a massive dense layer of rock called the mantle, and at the center, an iron and nickel core. Some extraordinary event must have occurred to transform the interior of the young planet. Geologists now believe that soon after it formed, the Earth completely melted.
Originally, the Earth was probably just a big collection of rocks like this, but it heated up to the point where these rocks all melted. And when that happened, the denser elements sank down through to the very core of the Earth, and the lighter elements floated at the top.
The huge gravitational pull dragged the heavy iron and nickel down to form the core and separated the rest of the planet into layers. What caused such a huge mass of rock and metal to heat up in the freezing depths of space puzzled geologists for many years.
We think it's from the incorporation of very hot radioactive elements. They're out there floating in space. As the Earth accretes, it includes some of this ferociously hot material. As it gets inside there, it begins to heat up the rocks around it. And if you build the Earth fast enough and you incorporate enough of this really hot radioactive elements, it'll be enough to melt the Earth from the inside out.
Only 30 million years after it began to form, Earth had become a giant round ball of boiling liquid rock and metal orbiting the sun.
Imagine a totally molten world. I mean, it had molten magma oceans, no dry land anywhere, no water, just flowing lava everywhere.
The temperature of the molten Earth was now a staggering 2,000 degrees. But at the edge of the planet, the vacuum of space is a constant minus 450 degrees. almost 2,500 degrees colder. The surface rock could not stay molten for long.
It's cooling from the outside in. So from the outside begins to crust over, and you get this little scab, like on a wound, of cooled rock, but still really hot, and then gradually begins to cool from the outside in.
In less than 1 million years, Earth's surface was covered in a thin crust. But volcanoes still spewed out lava and choking gases. Meteorites rained down in a constant bombardment. Earth had a long way to go before it could support continents, oceans, and life. Scientists investigating the earliest origins of the Earth have uncovered evidence from salt grains in space. They revealed that the Earth began to form when fragments of the solar dust clouds stuck together. The Earth's internal layers provide the clue that soon after it formed, the young planet completely melted. Scientists had worked out how the Earth first formed from a cloud of dust in space, but they were missing a vital piece of the puzzle. They still did not know the age of the Earth. Billions of years before humans evolved, tiny mineral grains in space clumped together to form the molten ball that became the Earth. But exactly when that happened is a question that has taxed the minds of scholars and scientists for centuries. In 1650, the Irish Archbishop James Ussher added up the ages of all the prophets and kings in the Bible. His calculations led him to very precise conclusions: that Earth was created at nightfall before Sunday, October 23rd, 4004 BC. A century later, geologists realized that Earth's thick layers of sediments and volcanic lavas must have been laid down over millions, rather than thousands of years. The next breakthrough came in 1897, when physicist Ernest Rutherford figured out that measuring radioactive decay could accurately date the age of rocks. Rock samples from around the globe were found to be not just millions, but billions of years old. But in their hunt for the age of the Earth, scientists hit a major obstacle. Rocks from the earliest stages in Earth history are very hard to find.
If you want to go back as a geologist and try to find evidence of those early days, it's very hard to do on the Earth because, of course, we have rain eroding, we have tectonics and continental drift destroying continental surfaces. We simply can't find the rocks that go back to that age.
In the early 1950s, the American geologist C.C. Patterson tried a new approach, using meteorites. He knew that meteorites must have clumped together from the same mineral grains in space that formed the Earth. And that happened at the same time as the Earth was born. So if he could date a meteorite, he should get the true age of the Earth. In 1953, Patterson came to Meteor Crater in Arizona, looking for samples. The meteorite which blasted out this enormous crater was about 50 yards across. It slammed into the Earth at a fantastic speed.
Objects hitting the Earth from space may typically come in at 10 or 15 miles per second, hitting the ground, penetrating into the ground, generating an enormous pressure and shock wave and creating a huge explosion.
The meteorite hit the Earth with the force of a 2 megaton atomic bomb. The explosion vaporized most of the meteorite, but individual fragments survived.
This is one of the pieces of the object that crashed into the Earth and made this crater. This is pure iron. We know it's iron because, for example, it's magnetic. An amazing piece of something that was floating in space. This was the kind of place that people could get samples for the first radiometric dating of meteorites. And so Patterson came here and got samples like this.
Patterson dated the samples and was amazed by the results. The meteorite was a staggering 4.5 billion years old, meaning that the Earth was also born 4.5 billion years ago. Patterson had solved the problem that had defeated scientists for centuries.
There's this apocryphal story that Patterson got so excited about the date that was coming back from the laboratory and so hyper about it, he thought he was having a heart attack. And he was driven to the hospital, and it turned out to be just his excitement over this fantastic discovery.
Modern radiometric dating techniques have refined the age of the Earth to a remarkable degree of accuracy. The most recent study dates the Earth as 4,567,000,000 years old. So scientists now knew how and when the Earth was formed. But nobody had figured out what happened next. Then in 1974, a radical new theory emerged. In the early solar system, there were dozens of mini-planets chaotically orbiting the sun. According to the theory, one of these was on a collision course with Earth. The idea was the brainchild of Bill Hartmann, who was trying to explain the origin not of the Earth, but of the Moon.
What we came up with was that maybe during that period of intense impacts, maybe very large impact hit the Earth and blew some crustal outer mantle rock off of the Earth into space around the Earth, and the Moon formed from that material.
Hartmann suggested that another planet, about the size of Mars, crashed into the Earth. He claimed that the Moon could have been formed by debris from that collision. To many scientists, this was nothing but fantasy, but Hartmann had evidence. Collected from the Moon itself.
I fall in the plum crater getting this rock.
Footage from the Apollo 16 mission in April 1972 shows astronaut Charles Duke struggling to pick up a large sample of moon rock to bring back to Earth for geologists to analyze.
That's 20 pounds of rock.
At the Johnson Space Center in Houston, this actual piece of moon rock is still kept under strict laboratory conditions.
I would say, behold the Moon. This is an actual piece of the Moon, and it's the largest single rock that they brought back from the surface of the Moon when the Apollo astronauts went there. We can't touch it. They don't want human beings touching these rocks and leaving organic material on them.
Until the late 1960s, geologists thought that the Moon formed in the same way as the Earth, by clumps of mineral grains sticking together in the solar dust cloud. They believed it had layers, like the Earth, and a heavy iron core. But when geologists analyzed lunar samples, they were astonished to discover that the moon rocks contained much less iron than they expected.
One of the mysteries has always been, why isn't there as much iron in the Moon as there is on the Earth if the two objects are right close together in space?
The question bothered Hartmann so much that he began to think that conventional theories about how the Moon formed might be wrong.
That lack of iron in the Moon, or to put it another way, the fact that the Moon is made out of rock that looks like the crust and the upper mantle material of the Earth, that was a clue that the Moon may have formed from rocks from the outer portion of the Earth.
This was the key to Hartmann's idea of a collision between Earth and another planet. The force of the impact completely destroyed the other planet and flung billions of tons of Earth's crust and mantle out into space and into orbit round the Earth. Within a few thousand years, this debris clumped together to form the moon. Advanced computer models show that the collision was a glancing blow. The other planet did not hit Earth head-on. This meant that while Earth's outer layers were ripped off, none of its iron core was blasted away.
That lack of iron would end up explaining why we have a moon that is only the rocky material without the iron material.
Hartmann's collision idea is now accepted as fact. It was his fascination with the moon that led to a new understanding about a vital stage in the formation of the Earth.
The moon always, to me, is a reminder that we live in a larger environment than just the Earth. It's the cosmic environment. The inner solar system is our environment that we can move around in now.
In the quest to discover the age of the Earth, evidence from radiometric dating of meteorites proves that the Earth was formed just over 4.5 billion years ago. The lack of iron in rocks brought back from the moon is evidence that the Earth survived a massive collision with another planet. But vital parts of the modern Earth were still missing from the newly born planet. The investigation now needs to figure out how the Earth gained two essential components: solid land and water. $4.5 billion years ago, Earth formed out of the solar dust cloud, then survived a devastating impact with another planet. The investigation now moves 200 million years forward in time as scientists try to discover how the first continents and oceans formed. They are looking for evidence on the northeast shores of Hudson Bay, Canada. This is the desolate landscape of Porpoise Cove, the site of an important new scientific discovery. And it's all down to a young PhD student's fascination with ancient rocks.
I was interested in studying the early Earth, so the idea is to get as far as we can back in time to get these old rocks and study rocks that were there in the past.
Geologists already knew that rocks in this part of northern Canada are extremely old. But something about a small area in this vast wilderness caught O'Neill's eye.
The overall aspect of the rocks really looked different. And right away we knew that something was really bizarre, really unusual about these rocks.
The rocks are highly altered, deformed volcanic lavas known as amphibolites.
The chemistry was unusual, the mineralogy was unusual, and nobody had seen rocks like that before.
O'Neill decided the rocks needed further investigation. He sent samples to be radiometrically dated. The results were astounding.
We were in the lab in Washington, D.C. when we first got the first number out of the machine. And the first reaction is we didn't believe it. So what you do is you reanalyze the rock a second time. And then the same number comes up, and then a third time, and then again and again. So you say, okay, we'll analyze more of these rocks because I can't believe it. And these numbers, the signature, this really, really old signature keep coming up, keep coming up, and keep coming up. And in the end, you have to come to the conclusion that these rocks have been formed nearly 4.3 billion years ago.
The results were indisputable. The amphibolites are 4.28 billion years old, 200 million years older than any other rocks so far discovered. They are the closest anyone has come to finding Earth's original crust.
These are the oldest rocks in the world, and it's amazing when you stand on it. You can try to imagine yourself almost 4.3 billion years ago when the Earth was so young and just barely forming. Walking on this landscape. And it's a really amazing feeling.
These rocks are now yielding clues about the thickness of the early crust. O'Neill has found unusual minerals which can only form in conditions of very high temperature and pressure. They prove that the amphibolites were made at least 12 miles down in the crust of the Earth. This means that more than 4 billion years ago, Earth had a solid crust at least 12 miles thick. And a crust that thick suggests there must have been continents. And there's more. Evidence hidden in the amphibolites reveals that these rocks must have originally formed deep underwater.
Well, you have to understand that when rocks form, they can record their chemical signature. And depending on where the rocks are formed and what geological context they will be formed, they will carry that specific chemical signature.
The chemical signature of the amphibolites is unique. It proves that when these rocks formed, Earth had not only a solid crust, but oceans.
The signature we see here, it really looks like an oceanic floor. That means there was an ocean and a lot of water already at 4.28 billion years old. So it totally changes our view of what the Earth was like before.
To the scientific world, this idea is dynamite. But O'Neill is not on his own. There is more evidence to back up his claim. In the same ancient rock sequence, geologists find another unexpected rock type called banded iron formations. These rocks are made up of alternating light layers of silica and dark bands full of a mineral called magnetite, which, as the name suggests, are rich in iron.
We usually use a magnet to try to find these minerals. It's a quick and easy way to identify for sure those rocks as banded iron formation.
Magnetite in banded iron formations only forms underwater. So these rocks are further evidence that there were oceans on Earth more than 4 billion years ago. But scientists don't know how much of Earth's surface was covered by water.
The only way to form this magnetite is to be like in an ocean. We don't know exactly what was the ocean at that time, but we know for sure that we need water to form those rocks.
These discoveries are forcing geologists to rethink their ideas of what conditions were like on Earth less than 300 million years after the planet formed.
People often think of this earlier like a ball of fire, a molten rock, but this is not the picture that we see here. We see that already at 4.28 billion years old, we probably had an ocean. We had continent that really, really looks like what we know today. So it changes totally our view of the early Earth.
The investigation has now revealed when the Earth's continents and oceans began to form. Evidence from amphibolite rocks at Porpoise Cove confirms that the Earth had developed a thick, solid crust 4.28 billion years ago. Banded iron formations in the same rocks show that there were oceans on Earth's surface at the same time. All of which raises another mystery. If oceans existed more than 4 billion years ago, the investigation needs to figure out where all the water came from. After its formation from the solar dust cloud 4.5 billion years ago, Earth was a fiery ball of molten rock. But 200 million years later, the first oceans were already forming. And Earth today is the blue planet, with 70% of its surface covered by water. The investigation now looks at the mystery of the origin of Earth's water.
One of the important questions I've always thought about is, where did all of this come from? All of this water, all the water in the oceans and in the atmosphere, in our bodies, in the ground. When you look at the Earth from space, what really impresses you is the water, how beautiful this planet is. Why does Earth have all this water? And how did it get here?
The question has puzzled geologists for years. Now, they believe the answer lies in space. New evidence showing how our water arrived on Earth has emerged from a meteorite that fell in 1998, but which has only recently been analyzed.
We found an astonishing thing. This meteorite contains grains of table salt, just like you put in on your fish and chips.
The clue is trapped inside the crystals of salt and revealed under the microscope. Minute droplets of liquid water.
On the computer screen, you can see a little fluid inclusion, a little drop of water, and you'll know it's water. We know it's liquid because you see a little bubble moving around inside of this little droplet of water.
The amazing thing about this discovery is the age of the water.
You can date this by several different dating techniques. The salt itself is 4.5 billion years old. The water inside has to be at least that old, if not even older. There's no question about it. And so this water is at least as old as the solar system.
Here is visible evidence that water existed in space when the Earth first formed. And Zelensky is convinced that meteorites then brought the water to Earth.
And so it's looking more and more like the water arrived drop by drop in rocks like this meteorite here, landing over the course of billions of years. You have lots of material coming in every day and smacking into the Earth and depositing a little bit of water, a few drops at a time.
The scale of the meteorite bombardment needed to fill the oceans with water is almost impossible to comprehend. But scientists believe that over billions of years, there were easily enough meteorites crashing into the Earth to account for all the water on the planet.
Gradually, those rocks are sweating water, building up first shallow seas here and there that grow to be giant oceans. So you go from this to this.
Once Earth had land masses and water, the stage was set for the development of life. The next phase in the evolution of the Earth. Life is an essential element in Earth's geology. Without life, sedimentary rocks like chalk and limestone would not exist. Without life, there would be no coal, oil, or gas. Life has shaped the Earth in profound ways. But finding the origin of life has challenged scientists for hundreds of years. Now there's a new explanation. It comes from evidence found at Allende in the desert landscape of northern Mexico. At about 1 a.m. on February 8, 1969, night suddenly turned into day.
A large fireball was seen travelling from the south northwards over northern Mexico. And this big flash and this fireball was caused by a really large meteorite. It was probably about the size of a car, and it entered the top of the Earth's atmosphere at about 36,000 miles an hour.
As it plunged through the atmosphere, the meteorite broke up into thousands of fragments.
There was no crater left by the Allende meteorite, so it fell as a shower of stones, the largest of which was reported to be about the size of a beach ball. The stones are found in, we call it a strewn field, and it's an area about 30 miles by 5 miles wide, and we're here right in the middle of that strewn field.
Because the meteorite fragmented into so many pieces, geologists had to search a huge area to find samples.
Now, I actually have a smaller one of the stones here. You can see it's about the size of a plum. It's one of the most primitive type of meteorites. This means that since it formed at the very earliest stages of solar system formation, really not much has happened to it.
When they analyzed samples from Allende, geologists made a groundbreaking discovery. The meteorite, contain tiny amounts of chemicals called amino acids.
Amino acids are terribly important constituents of things like proteins, and amino acids really are sort of like the chemical building blocks for life. So to find these amino acids, these molecules, within the meteorite was a really exciting discovery.
Every living thing on Earth, plant or animal, contains amino acids, and life could not exist without them. Until they were found in the Allende meteorite, scientists believed that amino acids were first made by chemical reactions on the surface of the Earth.
People thought that maybe life had started on Earth in these sorts of warm pools, maybe, a few 100 million years after Earth actually formed, or possibly through lightning causing chemical reactions in the early atmosphere. There was a few theories as to how life may have started on Earth prior to the discovery of amino acids in meteorites.
Since Allende, amino acids have been found in hundreds of other meteorites. Their discovery has revolutionized ideas about the origin of life on Earth. Scientists now believe that the building blocks of life originally came from space. Meteorites containing amino acids have bombarded Earth ever since the planet formed, and it was these amino acids which were the starting point for all life. Hunting for the origin of Earth's water and life, the investigation has revealed that the water on Earth arrived here inside meteorites. And meteorites also brought amino acids, the building blocks of life, to Earth from space. Scientists now need one more piece of the puzzle to explain the final stage in Earth's journey. From particles in the solar dust cloud to a planet where life itself builds Earth's geological features. $4.5 billion years ago, Earth formed out of the solar dust cloud. 200 million years later, the first continents and oceans were developing. Meteorites brought water and amino acids, the building blocks of life, to the surface of the planet. The investigation now moves forward to the period 3.5 billion years ago. New forms of life were about to emerge, which by their very existence would create new kinds of rocks. But life as we know it needs oxygen, and 3.5 billion years ago there was no oxygen on Earth. At the time, the atmosphere was deadly poisonous. Volcanic eruptions filled the air with a choking mixture of sulfur, methane, carbon dioxide, and sulfuric acid. But primitive life forms did exist. The fossilized remains of strange coral-like structures have been found in rocks more than 3 billion years old in many parts of the world. They are called stromatolites, and they are a clue as to how the atmosphere filled with oxygen. Living stromatolites are incredibly rare. One of the few places on Earth where they can be found is in another part of the northern Mexican desert. This is the high valley of Cuatro Ciénegas.
You might think that this is just any old desert, but it's not. This is a very special place because of particular way the chemistry is in this valley. It's unlike any other place on the planet.
The pool is like a time capsule laboratory. By examining the modern stromatolites, scientists can work out how they were made more than 3 billion years ago.
What's interesting about Cuatro Ciénegas is that this is almost like a proxy to right before the world had a lot of oxygen in it. And the place was dominated, our Earth was dominated by microbial life.
Seifert has discovered that the stromatolites are made by billions of microbes called cyanobacteria.
These right here are the stromatolites that are here at Cuatro Ciénegas. I have a piece of it here, and if you can see this blue-green rim, right here. This is millions and millions of cyanobacteria.
These bacteria were to change the course of Earth history because of one unique feature. They produce oxygen.
Here at this pond, we can actually see them doing their job. We can see them making that oxygen. So when I get in the water and I actually go up to one of these cyanobacterial mats, if I look very closely, all of the community is making oxygen. And as that oxygen collects in that mat, it produces a little air bubble. And you can watch that air bubble just transfer to the top, and that's actually when oxygen is being released to the atmosphere.
$3.5 billion years ago, oxygen was deadly poisonous to other early life forms, which used sulfur to obtain energy.
Cyanobacteria developed a little molecular machine that could actually take sunlight and take water, and they made a byproduct that was oxygen. Well, on this planet back then, none of the life was used to oxygen. And it's at that point in life's history when they began making excess oxygen that got into the atmosphere, our whole world changed in the way it worked.
Over geological time, there were enough cyanobacteria to produce trillions of tons of oxygen, creating the atmosphere we breathe today. And they were responsible for changing the way all life evolved.
From an evolutionary standpoint on planet Earth, we are where we are because of cyanobacteria and the fact that they managed to fill our atmosphere full of oxygen. Because unless we'd had that gas, we wouldn't have the complex organisms that we have on the planet. You and I wouldn't be here today.
Once the atmosphere began filling with oxygen, the stage was set for the evolution of all plant and animal life. The impact on Earth's geology was profound. Over hundreds of millions of years, decaying plant matter from tropical forests built up compressed layers, which eventually formed all the coal, oil, and gas deposits on the planet. Sedimentary rocks like limestone and chalk are made largely from the skeletons of marine animals which accumulated at the bottom of shallow seas. Without life, Earth's geology would be very different. The investigation into the birth of the Earth has uncovered evidence revealing the secrets of Earth's development. Experiments on salt crystals in space reveal that the Earth began to form when mineral grains in the solar dust clouds stuck together. Evidence from meteorites proves that Earth first formed 4.567 billion years ago. The oldest rocks in the world are evidence that continents and oceans were forming 4.28 billion years ago, much earlier than previously thought. Liquid water in meteorites proves that water was brought to Earth during billions of years of meteorite bombardment. 3.5 billion years ago, a billion years after it first began to grow out of the solar dust cloud, Earth had continents, oceans, primitive life forms, and oxygen. The birth of the Earth was complete. A new canvas on which billions of years of geological processes could mold the planet we inhabit today. Earth, a unique planet, restless and dynamic. Continents shift and clash. Volcanoes erupt. Glaciers grow and recede, titanic forces that are constantly at work, leaving a trail of geological mysteries behind. Among Earth's many geological wonders, there's nowhere more dangerous than Mount Vesuvius. It's a volcano well known for its violent past. As witnessed by the remains of its victims, frozen in time for nearly 2,000 years. But Vesuvius is still very much alive, and only now are its mysteries being revealed. a new discovery of a vast magma chamber of boiling hot rock beneath Vesuvius. Just one of many startling new clues to how the volcano could threaten one of Europe's most crowded cities with a fiery rain of death and destruction. Unlocking the secrets of Vesuvius exposes the awesome forces behind how the Earth was made. The next eruption at Vesuvius could kill more people than any other volcano in history. 3 million lives are at risk. On the west coast of Italy, towering 4,000 feet over the city of Naples, stands Mount Vesuvius.
The death toll would be big, running into the millions. So it really is the catastrophic nightmare scenario that we all fear.
The challenge for geologists is to figure out what could trigger Vesuvius's next eruption and assess how such a potential horror would unfold. The first catastrophic explosion would burst from the ground here, from the depths of the volcano's 2,000-foot wide crater.
Within seconds, the whole thing would be ripped apart.
It's the nightmare scenario that everyone fears. A cloud of fiery volcanic debris would blast down the steep sides of the volcano at 450 miles per hour, twice as fast as a Formula One racing car. Anyone within 10 miles of the crater would be caught in the eruption's death zone. Nothing could stop this boiling cloud of ash and rock.
Now, you might think that the people living across the water there in Naples would be safe from the volcano, but we know that that wouldn't be the case. It moves across the sea, picking up speed as it goes, not walking, but literally running towards Naples. Imagine the panic in downtown Naples as this hot, dark cloud of volcanic ash and dust descends on the city.
There's nowhere to hide. Men, women, and children are incinerated.
And the temperature's 600, 700, 800 degrees Fahrenheit. I mean, that's enough literally to boil the blood in your body.
Other victims suffocate. Anyone trapped between downtown Naples and the volcano is dead. Volcanologists had always believed that the city of Naples itself was safe from Vesuvius. They thought that even the volcano's biggest eruptions couldn't reach further than the city limits. A belief that was shattered by new research deep beneath Angevin Castle in the heart of Naples.
Wow, this is an extraordinary deposit extending from this level all the way up to this point, which makes it about 4 feet thick.
The layer Sheridan has found is an accumulation of ash that rained down on the center of Naples from a massive eruption in the Bronze Age, around 1780 BC.
It traveled 10 miles from the volcano across the Bay of Naples to this point.
Miles further than any other previously known eruption of Vesuvius. Astonished scientists could not ignore such convincing evidence.
Finding a deposit right in the center of Naples has changed the way people think about their safety from eruptions at Vesuvius. And people are now considering that Vesuvius may truly represent a risk to their safety.
If Vesuvius produced such a massive eruption once, it can again. There's a further monumental-sized piece of evidence that reveals the awesome scale of the blast in 1780 BC. These are the 3,700-foot-high cliffs named Soma. It's 4,000 years ago on Mount Vesuvius. A colossal eruption rips the volcano open. Molten rock blasts out of the cone, emptying out the underground reservoir that geologists call the magma chamber. This continues for hours until something literally earth-shattering happens. When the magma chamber empties past a critical point, the entire mountain collapses in on itself to fill the void below. The 1780 BC eruption was so massive that it brought down a mountain and emptied 63 billion cubic feet of pulverized rock onto the surrounding countryside. That's enough to cover the whole of Manhattan Island to a depth of 100 feet, or bury the state of Florida in almost half an inch of ash. This mega eruption is now the blueprint for Naples' worst-case scenario. It's one of the factors making Vesuvius the most dangerous volcano in the world. And it's why scientists are racing to prepare for the next disaster. To investigate what deadly forces could be unleashed on the city of Naples, scientists must understand the eruptions of its past. And no explosion is better studied than the one that destroyed Pompeii, the Roman city that lay 7 miles southeast of Vesuvius. In the year 79 AD, an eruption killed 25,000 people, 1/4 of the population, and left the area uninhabitable for 300 years.
Behind me here is the very material which buried Pompeii.
The volcanic debris is made up of ash and an unusual white rock.
Really, first impressions are that it's really rather light. And if I get in a nice close look there, the rock itself is absolutely riddled with holes.
The holes were bubbles of trapped volcanic gas.
Now, this light white rock is called pumice. Now, pumice is magma that's filled with bubbles so much that it'll actually be able to float. And pumice is the only rock in the world that can float.
The trapped bubbles show exactly how the pumice was formed.
The magma beneath the volcano is a bit like the cola in a sealed bottle like I have here. We have liquid and dissolved gas.
If the pressure is released suddenly, the dissolved gas explodes out in the form of bubbles.
The bubbles in the cola have turned it into a froth, and this frothy mass that's coming out of the cola is just like in a magma chamber. When the gas escapes from the magma, forms a magma froth which violently comes out the volcanic vent.
So the discovery of pumice proves that the volcano created magma foam. And that can only mean one thing. The eruption must have involved a major explosion.
The explosion sent the magmatic foam and ash over 17 miles into the atmosphere. This is twice the height of your average cruising aircraft.
Amazingly, there is a surviving eyewitness account of the disaster written 2,000 years ago. Every detail of the eruption was noted by the 17-year-old Pliny the Younger, who was, in effect, one of the world's first volcanologists.
Pliny, a naturalist, produced the first scientific recording of a complete volcanic sequence. He writes, "A cloud was forming. Its appearance and shape would best be expressed as being that of an umbrella pine, similar to this large tree I have behind me. Since, stretched upward like an extremely tall trunk, it then spread out like branches."
So the cloud spread out at the top, forming a mushroom shape, which is still known as a Plinian column. For Pompeii, this cloud was lethal. The pumice and ash was carried by the prevailing wind to fall like a deadly gray snow on the ancient city.
And it was this volcanic fallout that started to thicken the air. The people who were initially amazed by the volcanic eruption now started to find it difficult to breathe.
Many of the victims of Pompeii suffocated on the fine ash.
We see a picture of people struggling to breathe, like this body here, which is curled up with their hands close to their face, essentially recording the last final breaths of the people as they filled up with ash and hot, fiery dust from the volcano.
Such a rain of ash falling onto the crowded streets of Naples today would cause millions of casualties. In trying to solve the mystery of what makes Vesuvius the most dangerous volcano in the world, scientists have uncovered two crucial pieces of evidence. The pumice from Pompeii proves that Vesuvius can produce explosive eruptions, the most devastating type of volcanic blast. A thick layer of volcanic ash found underneath Naples shows that Vesuvius has the power to stretch out and destroy the city. A similar-sized blast today could kill 3 million people, which would be the world's highest volcanic death toll. Geologists know that some victims would die of suffocation, but the discovery of charred human bones are clues to another, more terrifying death wrought by Vesuvius. Geologists are investigating the deadly threat of Mount Vesuvius. Remains at the Roman settlement of Pompeii show how thousands died, buried by a choking rain of ash and rock. But in 1981, excavations 4 miles to the west of Vesuvius showed that an even more horrific fate awaited the people of this Roman town, Herculaneum. When the volcano erupted in the year 79 AD, Herculaneum was a busy resort town of 10,000 people. But surprisingly, when the ruins were first excavated, a mere 15 bodies were found.
And many people thought that that was because they could see the eruption early on and were able to escape. But when they dug down further, here to the shoreline and to these boathouses, this is where they found the truth.
The boathouses hid a grisly secret. These are the remains of the Romans caught trying to flee the volcano. The skeletons still lie exactly where they fell 2,000 years ago.
It's hard to imagine what it must have been like. Over 300 men, women and children here at the water's edge in Herculaneum. Here the boathouses providing shelter from the falling volcanic debris. And it was these boathouses that were going to become the final resting place of their tomb in Herculaneum.
For geologist Dr. Jerem, these remains hold the primary clue to exactly what happened during the eruption 2,000 years ago. The mass grave is treated like a crime scene. Photographic evidence is taken back to the laboratory for further investigation. The positions of the bodies themselves are the first clue to how quickly a volcano can kill.
Here we have a body that sat up against the boathouse wall in Herculaneum, and in the arms of this adult is a child. And they're sat there almost as though they were relaxing or resting against the wall. It's almost as though you could be sat there chatting with this person and then they've been killed.
There are further clues to be found in the fine detail of the victims' bones.
At the end of many of the bones, you see this blackened coloration. And this can be seen on many of the examples in Herculaneum. And it really seems to occur at the points, like here at a sort of elbow joint, the points on the body where there's very little flesh and the bone is very, very close to the surface.
For years, scientists debated what the discoloration could mean. Until in 1991, researchers from the University of Naples came up with a simple solution.
I'm going to recreate the one experiment that unlocked what happened at Herculaneum.
Dr. Jerem is burning several pig bones at increasingly superheated temperatures.
I'm going to rack up the temperatures, start to try and burn the flesh on the bones, and then hopefully get to the point where I can start to produce blackening of the bones and reproduce the colours that we see in the Herculaneum bone deposits.
Dr. Jerram burns one bone at 500 degrees and another at 700 degrees Fahrenheit.
The flesh is all starting to burn now, but clearly we're not really burning the bone here.
It is not until Dr. Jerram raises the temperature to 900 degrees that the bone itself is burnt.
Well, it finally looks like we've got somewhere where we're starting to burn the bone.
Scraping away the charred meat and skin reveals the bone underneath.
Here on this picture from Herculaneum, you can see on the end of this bone these brown into black transitions with some nice white bone behind. You know, this is exactly what we're seeing in the 900-degree experiment. So we can produce the blackened bone features that we see at Herculaneum with high temperatures, burning the bone that's exposed, but the bone that's covered by a bit of flesh gets protected and stays white. And this could be the only way in which we get these blackened bone features at Herculaneum.
The blackened bones show that on the day of the eruption, the air temperature 4 miles from the volcano reached 900 degrees Fahrenheit. That's hotter than the blast from an aircraft's jet engine. For years, scientists puzzled over how Vesuvius could have raised temperatures so high, miles from the volcano. But then, a totally different type of clue suggested the answer. At the small town of Boscoreale, just 1 mile southeast of Vesuvius.
This strange pillar-like structure, I mean, at first impression, it looks like some very strange, weird concrete post. But it's far more fascinating than that. And the clues are really in the base. We see a number of smaller structures radiating from the base. And these are actually roots. You see them feeding back into this big stump-like feature. This is a fossilized tree.
The tree was buried in volcanic material. As the original wood rotted away, it was replaced by rock and ash, which mixed with water and set like concrete.
Almost like a jello mold of a tree upstanding that was upstanding over 2,000 years ago.
The shape of the tree is deeply significant.
And as we work up this fossilized tree, it suddenly veers and bends at this point here. Now, if we can imagine, about 2,000 years ago, this tree was alive. And suddenly it's been wrenched over and bent towards that way, and it's also been fossilized in that position. Now, when we look at the local geography, we know that Vesuvius is over that way. So some force which is bending this tree and fossilizing it must have been coming from that region.
The clues of superheated temperatures miles from the volcano and a force that bent a tree almost double suggest only one thing. They're evidence that Vesuvius produced another deadly weapon. A pyroclastic flow.
Pyroclastic flows are a dynamic mixture of hot rock, ash and gases that move fast and violently down the side of a volcanic mountain.
These deadly boiling clouds reach speeds of up to 450 miles per hour, faster than a bullet train, and temperatures of up to 2,000 degrees Fahrenheit, hot enough to melt gold.
At the early stages of the eruption here at Herculaneum, you would have seen a big eruptive cloud coming out of Vesuvius and heading off up into the atmosphere. But just imagine how scared you would have been watching this cloud suddenly turn round and the black cloud starts heading towards Herculaneum. This cloud of hot material, hot, boiling, bubbling pyroclastic material starts to enter the city streets, starts enveloping you and heading off down towards the port. And that was it. The pyroclastic flows had hit Herculaneum.
Just hours later, the town was buried completely. Striving to understand how deadly Vesuvius can be, investigators have found vital clues to the devastation from the searing heat of pyroclastic flows of the past. Horrific burns on human bones prove temperatures got to a blazing 900 degrees Fahrenheit, 4 miles from the volcano. And a 2,000-year-old fossilized tree reveals the power of the speeding flow of hot rock, gas, and ash down the mountainside. But pyroclastic flows are not the only deadly force in Vesuvius's arsenal. It has an ultimate weapon: rivers of molten rock that pour down the mountainside to burn and bury all in its path. Vesuvius has yet another deadly weapon in its arsenal, one that was captured on film during its most recent eruption on March 18, 1944.
Cameras record the spectacle of Mount Vesuvius.
A 5-mile-high cloud of ash climbed into the sky over Vesuvius. Pyroclastic flows rushed down its slopes. But worse was to come. Floods of molten rock overflowed from the lip of the crater to swallow up entire Italian villages. 34 died, and thousands were left homeless. These rivers of magma on the surface of the Earth are called lava flows.
One of the most prominent features in Vesuvius landscape today is this river of molten lava, solidified lava, on the sides of Vesuvius.
There are significant deposits of the 1944 lava flow extending 12 miles down the side of the cone.
And looking at it closely, I can see that there are no bubbles.
Unlike the lightweight pumice that rained on Pompeii, this solidified lava is dense and hard.
And actually, that is the clue that is telling me that this was not an explosive eruption. This wasn't hurled into the air. Instead, the gases seeped through the lava before they came to the surface.
Only a very free-flowing and liquid lava could have let the gases escape underground in this way. And with very little explosive gas left inside the lava, it flowed out rather than burst out of the volcano.
Lavas will flow down the slope using the easiest way, and this is going to be very much the same path as water will take.
Floods of lava at more than 2,000 degrees Fahrenheit poured down the slopes. Lava flows are the hottest natural material on the face of the Earth, Vesuvius's ultimate weapon, an unstoppable force destroying all in their path.
The word lava, it actually comes from the Italian, and it was coined in here. It comes from lavare, which is to wash. And it is basically explaining how lava flows, once they move over a city, they wash out everything. Nothing is left.
Since 1944, Vesuvius has been quiet. A calm has settled on the people living in its shadow, and today Vesuvius is even a popular tourist attraction. But teams of scientists still go into the crater searching for any signs that the volcano may be awakening.
Okay, let's go.
It's a 1,000-foot drop to the crater floor.
Let's go down slowly. There are a lot of rock falling today.
The volcano is crumbling in on itself. The walls made up of loose rock thrown out in the 1944 eruption are slowly collapsing back into the crater. Even before he reaches the bottom, Orsi can see and smell gas and feel the heat of volcanic activity.
Yeah, the smoke you see around here, it's gas coming through fumaroles.
A fumarole is a crack in the Earth's crust which emits steam and gas from deep underground.
And it's an indication, one of the indications that the volcano is still active.
A live volcano positioned next to a city of 3 million needs to be under constant surveillance. So much so that it is now the most closely monitored volcano on Earth.
Composition of the gas and temperature, it's related to the state of the volcano.
These gases are the volcano's early warning system. Any significant change in their temperature or composition would set the scientists' alarm bells ringing. Today's examination shows no change. So, for the moment, Naples is safe. But this lack of activity is not necessarily a reassuring sign.
So I think there is a pattern on how Vesuvius behaves in terms of you seem to have a period of quietness, and then you have a very large eruption, and then you tend to have a period of quietness, and then another large eruption.
So the danger is, the longer the volcano stays quiet, the more magma is allowed to accumulate. So when it does finally erupt, the bigger the blast will be. New clues at Vesuvius have concerned the volcanologists who were investigating its deadly power. Dense, solidified rock is evidence that Vesuvius possesses the ultimate weapon: high-temperature lava flows capable of destroying all in their path. Hot fumaroles in the crater prove the volcano is still active. But new scientific techniques reveal a vast magma bomb hidden miles underneath the volcano. A bomb that is primed and could blow at any time. Scientists have uncovered clues suggesting that the awesome power of Mount Vesuvius could soon be unleashed in a massive and devastating explosion.
For an eruption to happen, volcanoes need two things. They need a source of magma, which is a magma chamber close to the surface, and they also need a trigger. It's a bit like a bomb and a fuse. So once you have these two things in place, it could blow at any time.
The key evidence is bubbling up through the ground just 10 miles west of the volcano.
So my overriding sense of this area is one of intense heat. When all around me, it's not just the sun that's hot and baking down, and there's steaming gas coming out of the ground and cracks and fissures. So if the whole ground is kind of alive with thermal activity. And it just tells me, screaming out loud, that there's heat just percolating up from the ground towards me.
The steam gets to temperatures as high as 300 degrees Fahrenheit.
And the steam is also coming up with a gas called sulfur dioxide, and I can smell it really strong. In fact, it's almost choking when you get the wind blowing it into your face. So the telltale sign of this activity, the sulfur dioxide activity, is the coating of yellow material, yellow sulfur crystals, on all the rocks around me. There's only one thing on Earth that can drive this kind of activity: the sulfur, the hot geothermal springs, and the hot gas, and that's magma at quite shallow levels.
For years, scientists have known that a chamber of molten rock lies under Vesuvius, but nobody could see it. Then, in 2001, geologists used a pioneering new technology to investigate the ground under and around the mountain. It's similar to the way a doctor uses ultrasound equipment to reveal the shape and size of a human baby in the womb. At Vesuvius, volcanologists used sound waves, billions of times more powerful, to take a picture under the Earth. They detonated small explosions at different locations around the volcano, radiating waves out under the ground. Measuring the speed of the waves reveals whether the rock through which they're traveling is solid or more liquid, hotter or colder than the surrounding ground. Computers mapping the wave movements from the surface print out a ghostly but terrifying shape.
For the first time, seeing that sort of information is very exciting for geologists.
The magma chamber is so wide, it stretches well beyond the 1-mile base of the cone itself.
It's 250 square miles, or about half the size of New York City, so that's quite an impressive feature.
It's not only impressive, it's also potentially deadly. The vast reservoir of molten magma could fuel Vesuvius's greatest eruption. But still, no one knows for sure what might set off this seemingly inactive magma.
Well, there's some really exciting evidence that's been found that suggests that Vesuvius might have a bit of an unusual trigger.
In searching for the secret trigger mechanism of Vesuvius, Dr. Petford examines the pattern of when past eruptions have occurred.
What this line here represents is a timeline from 1600, where I'm stood, up to pretty much now.
Each stick represents an eruption of Vesuvius during the last 400 years.
And the first one is here at about 1631. And then there have been 3 more significant volcanic eruptions.
As the timeline takes shape, Dr. Petford inputs more data. This time, the dates of another seemingly unrelated set of natural disasters.
We've got records of earthquake activity as well. So I'm going to use these stones here to represent earthquakes. And these would be earthquakes that took place within about 100 miles of the volcano.
As Dr. Petford positions the major earthquakes of the last 400 years, a pattern emerges between the tremors and activity at Vesuvius. It has been possible to investigate this supposed link only because there are such uniquely detailed records about the volcano. Vesuvius has been inhabited for so long that every one of its eruptions of the past 1,000 years has been meticulously documented. Also, the volcano sits in an earthquake hotspot. This region experiences more tremors than anywhere else in Europe, activity that has generated further detailed records for geologists to study. When all this information was analyzed together, a statistically proven link was found. The evidence for this relationship is convincing at Vesuvius. But the idea that earthquakes can cause eruptions is still hotly debated worldwide.
The idea that earthquakes and volcanoes are related is not a new idea. In fact, it was Charles Darwin on his journeys to South America in the 1800s who first proposed that there could be a link between an earthquake and a volcano he saw erupt a few days afterwards.
Darwin was in Chile in 1835 when an earthquake struck. Days later, he witnessed the eruption of a chain of volcanoes. To him, the relationship was clear that one was the cause of the other.
And really since then, over the last couple of hundred years, geologists have debated back and forward how real, if you like, this cause and effect relationship is between earthquakes and volcanoes.
Despite continuing controversy, many scientists do believe that the next huge eruption from Vesuvius may be triggered by an earthquake. The theory suggests that pressure waves rippling through the Earth's crust can squeeze the magma chamber.
If you imagine that this bottle represents a magma chamber down beneath a volcano, and that the water inside the bottle here is lava or magma, then as the earthquake pressure wave moves towards the magma chamber, it interacts with the walls and starts to squash the chamber. Chamber walls sort of pinch together like this, and it drives the magma up to the surface.
But even then, the eruption may be delayed. Historical records suggest the volcano may not stir for months or even years after an earthquake has passed.
There could be some good reasons for that. I mean, one might be that the earthquake builds up pressure slowly inside the volcano.
So the effect of the pressure waves are not immediate.
Or that you need more than one earthquake. You might need multiple earthquakes that progressively increase the pressure inside the volcano.
Each wave squashing the chamber a little more each time.
Until the last earthquake that comes along is effectively, the straw that breaks the camel's back, and it's that earthquake that pushes the system into critical instability and makes an eruption.
After thousands of years of study, scientists still do not fully understand what causes an eruption.
So an important thing about Vesuvius is that if we can make sense of this data set that we've got for this volcano, if we can come up with a new model for earthquake-related volcanic eruptions, Vesuvius could be the world leader in helping us to understand how other volcanoes on the planet might work in a similar way.
If earthquakes are the trigger for Vesuvius, then it is possible that the next eruption may already have started. Two massive earthquakes recently sent shockwaves racing through the ground near the volcano. In 2002, the first quake struck just 40 miles northeast of Vesuvius. This was a magnitude 5.4 tremor. 30 people died and thousands were evacuated from their homes. Even more recently, in 2009, a magnitude 6.3 earthquake killed more than 300 people in the town of L'Aquila, 60 miles north of the volcano. This was the worst such disaster in Italy for 30 years. The concern is that the shock waves from these quakes may already have shaken Vesuvius's monstrous magma chamber and triggered the start of a new eruption. The clues are adding up in the race to predict when Vesuvius will erupt. Scientists have gathered two startling pieces of evidence. A huge magma bomb beneath Vesuvius proves the volcano is primed with the fuel for a massive explosion. The historical pattern of earthquakes and eruptions suggests the trigger may already have been pulled. Each new piece of information takes scientists one step forward in their quest to foretell when Vesuvius may blow. But even predicting the eruption may not be enough to save the lives of the 3 million citizens of Naples. Recent discoveries around Vesuvius reveal that if a blast like the one in 1780 BC occurred today, it would reach the heart of Naples, a metropolitan area with 3 million people.
Vesuvius is an active volcano and it's also explosive, so it's quite dangerous. In addition to that, there is a very large population living around Vesuvius, so also the risk is very high.
Studies of the surrounding landscape suggest that the volcano's most lethal force, the pyroclastic flow, would not only reach Naples, but would be concentrated down in the direction of the city. The high cliffs of Somma partly surround the cone of Vesuvius. If there was an eruption, these walls would act like a funnel, channeling the majority of the boiling volcanic debris to the west, straight towards the city. Vesuvius is like a loaded gun pointed right at Naples.
The new evidence that we have is really important. It points to one very critical point, that Naples is not safe. This area could be hit, it could be targeted.
This new information, in addition to the discovery of volcanic deposits in the heart of Naples, has spurred the city to review its 2001 evacuation plan.
The evacuation plan currently only deals with those people who live on the slopes of Vesuvius in the villages and towns around. That's about 600,000 people. The city of Naples, here where I am now, isn't presently included in the evacuation plan, and of course that's where the majority of people live.
Geologists are key to putting new evacuation plans in place. But planning is the easy part. Knowing when to put those plans into action is the most difficult call to make.
The decision of evacuating or not and when to evacuate is probably the $1 million question.
If scientists seem to exaggerate a threat and recommend an evacuation, the next time people might not pay attention.
If they're evacuated too late, the price might be thousands of people dead.
It's a dilemma faced by volcanologists around the world. Mount Vesuvius is only one of 3,000 active volcanoes. 9% of the world's population, some 450 million people, live in areas threatened by a volcanic blast. Mount Rainier stands 54 miles from the 500,000 residents of Seattle. Popocatépetl is located 44 miles from 9 million people in Mexico City. And Mount Fuji stands 60 miles from the 12 million citizens of Tokyo. On average, 3 volcanoes a year erupt, causing deaths and injuries. The hope is that lessons learned from Vesuvius will one day help protect people around the globe. Mount Vesuvius still has many secrets to tell. But so far, geologists have put together a disturbing portrait of what many call the world's most dangerous volcano. Pumice from the ruins of Pompeii, evidence of the explosive power of Vesuvius. Charred human bones demonstrate the 900-degree temperatures of the mountain's pyroclastic flows. Ancient layers of ash in downtown Naples prove that Vesuvius has the power to engulf the city. And new seismic investigations reveal a 250-square-mile magma chamber sitting under the volcano. It's a ticking time bomb. Geologists who study how the Earth was made believe that it's a geological certainty that Naples will one day feel the wrath of the volcano. Even now, Vesuvius is armed and waiting for its next eruption. Dynamic proof that the Earth is never at rest. Earth, a unique planet, restless and dynamic. Continents shift and clash. Volcanoes erupt. Glaciers grow and recede. Titanic forces that are constantly at work, leaving a trail of geological mysteries behind. None greater than the Sahara Desert, the hottest place on the planet, a deadly wasteland that time forgot. Or so scientists believed, till they unearthed a series of startling clues. The fossils of sea creatures, freshwater shells buried in sand, ancient settlements with human remains. Clear evidence that this stark landscape hides a turbulent past. One that would alter the course of human history and provide a dramatic new chapter in the story of how the Earth was made. Africa's vast Sahara Desert is as big as the United States. The sand alone from this giant expanse could bury the entire world 8 inches deep. It's the largest desert and the hottest place on Earth.
When I first arrived in the Sahara, I was just struck by how utterly barren it was. It's like the color green was removed from the palette when they made this place. Just nothing, grays and browns, and not a scrap of life.
Smith's mission is to unearth evidence of what made the Sahara into the wasteland it is today. Her investigation begins on the desert's far eastern edge, in Egypt. Not in the sands of the Sahara, but in one of the most epic structures ever built by man, the Great Pyramids. The building blocks of this ancient wonder house a remarkable clue to the history of this land, from a time long before the pharaohs even existed.
So, taking a closer look at these blocks making up the pyramids, there's actually these gorgeous marine fossils in here. Most obvious are these flat discs up to about an inch wide. They're called nummulites, and they're actually single-celled organisms.
The name nummulites means little coins in Latin. They are some of the largest single-celled creatures to have ever existed. In ancient times, these blocks were cut from quarries across the country and dragged to the pyramid site. Each block weighed 2.5 tons, and it took 2 million of them and over 20 years to build the Great Pyramid. And incredibly, up to 40% of each building block is made up of the bodies of ancient sea creatures like these. What's even more important about the marine nummulites is that they date back 40 million years, and they only lived in water.
It's a piece of evidence that this area, now desert, was once underneath the ocean. You think about the construction of the pyramid, but not necessarily about what it's made of in these gorgeous fossils.
The Sahara now is the world's biggest dust bowl. But the tiny nummulites fossils suggest that it was once very different, that perhaps there could have been water in this barren wilderness. Smith heads further inland to investigate this extraordinary idea. She travels to a remote desert valley near where the pyramid stones were quarried. It's called Wadi al-Hitan. Spread out in the sand lie hundreds of fossils, first excavated in 1983. But these are nothing like the tiny nummulites.
That's a whale. So here's the backbone, the vertebrae. Here's some ribs, shoulder, part of the front fin, and there are the jaws. This guy definitely did not live in a desert.
This incredible fossil is a Dorodon, an ancestor of modern whales, one that died out 36 million years ago.
So based on the size of these vertebrae and how much of the animal was here, it was probably about 21 feet long. This guy tells us that we were underwater. We were in the middle of an ocean.
Wadi al-Hitan is Arabic for Valley of the Whales. This 12-mile dip in the landscape has the highest concentration of fossils in the world. Some were found in the desert floor, others in the cliff walls. The count so far is 400. Almost all are marine animals. Further evidence that the Sahara was once covered by sea.
So here we've got the fossil of a baby whale. You can see the lower jaw down here with some teeth, and the shoulder, the backbone, some ribs, and all curled around. Actually, the tail comes right back to near the head.
As if finding whales in the desert wasn't intriguing enough, there's yet another mystery to be solved. A lot of the fossils are of very young Dorodons, like this one. A delicate mesh of stone helps explain why so many baby whales died in this place.
Wow, so finding that whale fossil told us we were in the ocean. These rocks actually tell us a lot more about what type of ocean we were dealing with. These are all fossilized mangrove roots.
These roots would have been below water. The mangrove trees would have risen above it.
Since trees don't grow out of the deep ocean, we know that this area was actually under shallow ocean at the time these rocks were deposited. Something probably that looked like the Florida Everglades, where there are mangroves growing now.
Smith has discovered the shoreline of the ancient sea. The shallowness of the water could explain why there were so many young animals here.
So one idea, there's a bunch of these baby whale fossils found in this area, and this would have been a shallow protected bay that maybe the whales came just to birth their young. It is absolutely incredible to see a fossilized whale in a place that right now gets less than 1 millimeter of rainfall a year. It's as much convincing evidence for geologic change as I can imagine.
The pieces of the puzzle are coming together to reveal the Sahara's watery past.
So 40 million years ago, this desert would have been covered in the middle of this valley by a shallow bay, probably a brilliant tropical blue-green color. The shoreline would have been off along the horizon, some mangrove trees in the shallowest parts of it.
Inland would have been a vibrant combination of rainforest and swampland. The whales would have been drawn to this ancient shore because of the plentiful supply of food. But their ocean is about to vanish. Marine fossils found in Europe and Africa are evidence that this ocean stretched almost halfway around the world and connected Asia to the Atlantic. It's called the Tethys Sea, and much of the Sahara was submerged under it. The mystery is how and when this lush water world turned into the barren wasteland we see today. The answer lies not in climate patterns, but in geology. The entire African continent is underpinned by a giant piece of the Earth's crust. It's called a tectonic plate, and 40 million years ago, in what is known as the Eocene Age, it was on the move.
So at Wadi al-Hitan, we have whales swimming around in this Eocene Ocean, all the while the African plate is moving to the north.
Africa collides with Europe, closing the Tethys Sea. But the African plate keeps moving.
So we uplifted the northern part of Africa, and so the Tethys Sea recedes. And we've got this whole area of North Africa now emerged. It's out on land.
The whales of Wadi al-Hitan are cut off and trapped in smaller and smaller pools of water. The deadly Sahara has claimed its first victims. In the quest to discover the history of the vast Sahara Desert, geologists have so far uncovered 2 important clues. Sea fossils in the Great Pyramids of Egypt show these building blocks were once underwater. Whale bones reveal that a sea submerged much of the Sahara 37 million years ago. As the forces of plate tectonics pushed the Sahara out from under the sea, it created a tropical swamp. In order to figure out what made it into the wasteland visible today, scientists have to pinpoint the moment of its birth. But the clues to this mystery turn out to be hidden in the last place anyone expected. 20 million years ago, the Sahara Desert was a lush tropical swamp. Geologists are now piecing together the story of the next 20 million years. Today, the Sahara lies in what is known as the Desert Belt, a region of dry air north of the equator. Here, strong winds clear the sky of clouds and dry out the land below. It stretches through the Gobi Desert in China and across the deserts of the southwestern United States. The Sahara is the largest, and yet geologists know next to nothing about when it was created.
What we have are just these little bits and pieces, these snapshots of what the Sahara was like, because the wind blows away a lot of our record, and what isn't blown away is often covered by sand, so it's kind of hard to find the rocks we need to tell the story we're trying to tell.
One of the few places that shelters a clue to the Sahara's birth is the White Desert. In this hauntingly beautiful site, dramatic shapes have been sculpted out of rock.
Oh, this is great. It's got that mushroom shape.
These structures are called yardangs, and they are a kind of hourglass that could help measure the age of the desert.
This rock is another piece of evidence that this desert was once under the ocean. It's actually a chalk made up of billions of little marine microorganisms. These chalks are actually really easy to erode, so that's one reason things are so beautifully sculpted by the wind.
But the wind is a brutal creator. It picks up sand and hurls it at the Yardang.
When wind scours or sandblasts the rocks, this is the characteristic shape that we get, this mushroom shape, narrower in the middle. That's because the wind goes faster as you move up from the ground, so it can erode harder, but it has less sand in it since it picks up the sand from the ground. So where we get the most erosion, where the rock is narrowest, is where we have the best mix of fast wind and the most sand.
40 million years ago, the top of the Yardangs formed part of the solid sea floor. But the wind picked up once the Sahara turned to desert, and the process of carving out these shapes began. Figuring out how long that took could help pinpoint the age of the desert.
It's hard to say precisely how long it would take for the wind to carve this all out. Something like this, about 15 feet high, soft rock, you're looking at maybe only tens to a few hundreds of thousands of years. But to carve out the whole Oasis Depression, you've got to need at least 1 million years.
But geologists suspect the Sahara is older than 1 million years. In their search for a more accurate date, they next turn to its most iconic feature: sand dunes. Here in the Sahara, sandstorms kick up that can last for 4 days. The sand is hurled across the terrain. Over hundreds of thousands of years, it accumulates into dunes that can tower 50 stories high. Perhaps these mountains of sand hold the secret of the desert's great age.
As soon as the climate becomes arid, you can start building dunes. And if we want to know how long that took, we can try and date the dunes themselves, but that's really hard.
What's hard is that these dunes are constantly shifting. The wind that builds them also blows them away, moving them an average of 50 feet a year. To get a precise age for the desert, scientists need to follow the sand to the end of its journey.
Coarse sand travels slowly and doesn't go all that far, but the finer particles will actually travel further. And so dust-sized particles actually can get carried out into the Atlantic.
The Sahara is the largest source of dust on the planet. 500 million tons of it ends up in the Atlantic every year. Some of it reaches as far as Florida and creates spectacular red sunsets. But much of it settles on the ocean floor, a treasure trove of information about the Sahara's past.
What's wonderful about working with the ocean sediments is that they capture everything. They're this very faithful recorder of the sediments that are raining down from the surface.
In 1995, Domenical drilled down into the ocean floor through layers of mud dating back millions of years. Each layer of sediment is like a time capsule. Shallow levels show plenty of this dust blown over from the desert. So Domenical extracted deeper core samples from over 1 million years ago. Still, there was desert dust. Finally, he dug down to a layer that was laid down 3 million years ago, and there, the dust finally stopped. It had taken a voyage to the ocean floor to uncover the turning point from humid tropical landscape into searing desert.
That's a pretty amazing change. You don't think of something as large and expansive and fixed as the Saharan desert as being something capable of such profound changes. And yet this is what the geologic record was telling us.
Domenical had finally solved the riddle of the sands. The Sahara has been a desert wasteland for 3 million years. In the search to discover the age of the Sahara, geologists have unearthed 2 startling clues. Yardangs show that wind-blown sand has been blasting across the desert for at least 1 million years. Deep-sea cores give a more exact date. The Sahara first turned from swamp to sand 3 million years ago. From that moment on, the Sahara became the searing wasteland we see today. It seemed that geology alone could explain the creation of the world's largest desert. Then, A new radar fitted to the space shuttle revealed a striking clue that the desert once harbored a slash of green across its burning sands.
Booster ignition and liftoff.
In 1981, the space shuttle made a surprising discovery. Using a new type of radar, NASA took a 30-mile wide scan of the Sahara Desert. The radar pierced the sand to a depth of 16 feet and revealed what looked like a hidden network of ancient waterways crisscrossing the desert. This finding stumped scientists. 3 million years ago, the Sahara turned from rainforest into desert. Now it seemed that it had been home to a lot of water at some point in the following 3 million years. Researchers followed the NASA images north into Tunisia, to the edge of a deep depression in the Sahara, the site of their first clue.
This is what we're looking for. Got some quite intact shells here. This deposit is largely composed of intact shells.
And these are not shells from the ocean.
So here we have half of a Cadastroderma glaucum shell, which is a clear sign of a freshwater lake. This is just one example of what must be millions of shells. We must be somewhere near the shoreline of the lake here.
Further shell deposits revealed that this lake was giant, about the size of West Virginia. But the shells provide even more remarkable evidence: the date when this lake existed. Carbon dating puts them at 90,000 years old and leads to one conclusion.
To have all these shells here, we must have had a lot of rain falling in the vicinity of this lake and a green Sahara.
Scientists fanned out across the Sahara to investigate other satellite images. They searched for any dips in its landscape that looked like they once held a body of fresh water.
So what was really exciting for me about those radar images that were produced by NASA, we can link this to the GPS, and we're finding evidence of lakes throughout the desert. And some of these lakes are massive.
3 different lake locations were confirmed by the presence of freshwater shells. The series of ancient lakes were so large, they've been dubbed mega-lakes.
So this is the far shore of the mega lake. And there's just one of many lakes across the green Sahara.
When Drake added up the evidence of all the lake locations, he uncovered an astonishing fact.
Okay, so if this is North Africa here, and this is the edge of the Sahara Desert, so we're here in Tunisia with a mega lake here, and we know there's another mega lake here in southern Libya, an even larger one here in Chad. If they all meet their maximum size, they would have covered 10% of the Sahara.
That would have made them 3 times larger than the Great Lakes. What is now the biggest desert on Earth was once home to some of the planet's largest bodies of fresh water. Sudden changes in climate have been connected to everything from volcanic activity to meteors hitting the Earth. But climate researcher Peter Domenical had a hunch this wasn't the first time it had happened. He turned to his archive of deep ocean cores.
Our approach was to use deep sea sediments as this continuous tape recorder, if you will, of past climate change in Africa.
By looking at the levels of desert dust in cores dating back hundreds of thousands of years, he discovered the Sahara had changed more than once.
When we first collected these measurements, I really kind of almost fell back in my chair because what we saw was there are many switches like this in the climate system.
To explain these regular dramatic changes, Domenical looked beyond the Sahara to the rotation of the Earth itself. More specifically, small wobbles in the Earth's orbit around the Sun. The theory is that the wobble causes the Earth to tilt slightly. So the monsoons which drench southern Africa today shift up pouring rain onto the dunes of the Sahara. Crucially, these wobbles occur every 20,000 years.
So there's this perfect one-to-one match between when Africa was wet and the stage of the wobble cycle. And this goes back millions of years.
Each time the rain belt moves up, the landscape is transformed and the desert turns green.
To me, the single most impressive thing about the Sahara is how small fluctuations in something as simple as a wobble in the Earth's orbit can lead to these really just totally dramatic changes in the climate of a region that's so large.
Scientists now had evidence of how and why the Sahara turned green. They knew that giant lakes covered much of the desert, but they had no proof they were connected. Were these vast, isolated rain pools or part of an interconnected river system, as suggested by NASA's radar images? Nick Drake gets word that in 2009, archaeologists have made an important discovery that supports the river theory. Stone tools found not far from the site of the megalake in Tunisia. The first step is to identify the shoreline of the ancient lake.
Ah, now looks good. So, we've got some freshwater mollusks.
These tiny shells are a good sign of the lake. Now he searches for what may have been drinking the water when the megalake existed.
We have what looks like a part of a jawbone of a small herbivore. You can see 3 teeth running along there. Some sort of gazelle.
So animals must have existed here in the desert when it was green.
Okay, so we've got a stone tool here. It's become blunted, and they've retouched it with a lot of very fine flakes off the edge. The fact that we've got stone tools and we've got dead animals suggests hunting. And this was the animal that had been hunted. And then we've got water, so people sitting around a water hole waiting for animals to come to drink and then killing them, eating them, leaving them behind.
It's an important find. A Stone Age tool shows people lived on the shore of this ancient lake. And 90,000 years ago was a turning point, not just in the story of the Sahara, but in the history of humanity itself. We are all descended from one group of people in East Africa, the birthplace of humankind. Sometime between 80 and 120,000 years ago, modern humans started the long journey out of Africa. No one knows for certain what route they took. The prevailing view is that the Sahara was impassable, so humans left East Africa and traveled to the coast, then crossed a land bridge into the Arabian Peninsula. But Drake suspects that if the megalakes were fed by a river system, it would have created a green corridor across the burning sands.
So our ancestors could have followed these river systems, gone round the lakes, followed the next river system, round the next lake, and the next river system and the last lake, and then they've been in North Africa, and it'll be simple for them to just move out. The lake is a good story. The rivers plus the lake is a very concrete story.
To find proof of his theory, Drake heads to one of the few areas in the desert where water still flows, an oasis. He finds a small spring that shelters a valuable clue.
Caught some. Great. Cichlid fish. Nearly all cichlid fish are found south of the Sahara Desert. This particular type of cichlid is the only example north of the Sahara Desert.
This cichlid bears a strong resemblance to its closest relative that lives in Lake Tanganyika. But this lake is almost 3,000 miles away on the other side of the Sahara.
So the big question is, how did it get it? And the most obvious answer is that it swam across the green Sahara. Modern humans, who could live in lots of different types of environments, would have presumably found it very easy. A darn sight easier than this fish.
These rivers and lakes were not to last. The door slammed shut on the green corridor. But scientists now know that the Earth's wobble makes the Sahara like a pendulum. It goes from wet to dry every 20,000 years, like clockwork. The investigation has now revealed 2 clues to how these wobbles affected the Sahara. Freshwater shells dating back 90,000 years prove the desert was once covered by giant freshwater megalakes. A cichlid fish shows the Sahara was crossed by a river that created a corridor of life across the sands. But scientists still needed concrete information about how rapidly these changes occurred. Then, an Egyptian archaeologist made a stunning discovery in the Libyan desert. An eyewitness account of the Sahara's last switch, the most dramatic climate change of the last 10,000 years. Scientists piecing together the history of the Sahara have uncovered a remarkable story. 40 million years ago, it was covered in ocean. 3 million years ago, the Sahara turned to desert. Since then, it has swung between grassland and wasteland every 20,000 years. Scientists now turn to the more recent geological past, the last 10,000 years, to discover how fast this giant desert can change. Investigators head to a valley deep in the Libyan desert. The first clue to unraveling the mystery is a small circle of stones.
This is essentially the foundation of a hut. It is unimaginable to see an actual house structure right there next to what is now nothing.
Hassan's discovery is striking evidence of human habitation.
The house structure consists of this circular foundation with upright standing blocks which are taken from the local bedrock. It would have made a semi-circular structure with probably skins and branches, and people would have used that as a shelter.
Hassan believes these huts could have housed a small community of around 50 people. Now he needs to know exactly when they lived here.
Ostrich eggshell beads.
These little ostrich egg beads are clearly human handiwork.
They use the eggshells to make ornamental beads cut into a circle so that a string can pass through. So they string these into bracelets or necklaces.
The eggshells the beads were made from are also here and provide the next clue.
The eggshells suggest, of course, that they were ostriches, and that's quite remarkable for this environment to have animals like that.
This was no nomadic tribe, but a settled farming community rearing animals for food. Hassan carbon dated the ostrich eggshell beads. The result? Just 7,000 years ago, the deadliest desert on Earth was home to both human and animal life. It's dramatic evidence of the last burst of green in the desert. A dip in the desert floor provides a clear sign that rain from the monsoon fell here.
What we have here is the evidence of a deep lake with mud deposited.
This mud indicates a body of water that could have supported a settlement of people.
When the lake is deep, as we can see from these layers here, then there would be a lot of vegetation, a lot of animals, and people would have a very good time.
At sites all across the Sahara, scientists have excavated similar evidence of life. The remains of elephants and gazelles, hippos and crocodiles. Remarkable cave paintings even show people swimming. Elsewhere, human bones have been found, carefully buried in what were lakeside graveyards. Analysis of these bones reveals they date from between 10,000 and 6,000 years ago. The question now for scientists was how quickly the Sahara changed from bountiful back to bone dry. Earlier, deep-sea cores had provided evidence of the moment the Sahara first turned to desert 3 million years ago, and of how, since then, a wobble in the Earth's axis has made it swing like a pendulum between desert and grassland. Now, climate researcher Peter Domenical's on the hunt for the Sahara's last switch from green to desert, one that occurred in the last 10,000 years. To a geologist, opening this core is like a portal back in time.
Wow, that's amazing. Much, much redder in the upper part of the core.
Laid down flat, every quarter inch of sediment in the core represents 200 years. The color difference in the sediment is subtle, but to a practiced eye, it's a big clue.
When we split this core, what is surprising about it is that we see this really impressive color change, and it goes from this sort of darker green-brown color in this section of the core, which comes from the clay minerals that make up the deep-sea sediments. This bright red sediment actually comes from the wind-blown dust that's coming off the Saharan desert. As you move along this core, you can see this color maintains itself further up and up in the core. So right now we're about 7,000 or 8,000 years ago. Boom, here is the drawing of the Sahara. You can put your finger on it in this core right here at 5,500 years ago.
Crucially, the proximity of these two layers reveals how quickly the switch happened.
The transition from a very well-watered, wet Sahara that was completely vegetated to one that was much, much drier, that climate transition in this core occurred within 1 or 2 centuries.
Scientists knew that the Sahara was an ever-changing environment. Now, for the first time, they had a sense of just how fast it changed. As the Earth wobble shifted the rain belt away, the return to desert was swift and deadly.
These transitions would have happened almost on a generational timescale, that one generation after the next would have realized that where they're living is no longer sustainable.
High above the ruins of the lake settlement, Fakhri Hassan has discovered a cave he believes was important to the Saharan people during this sudden change in climate. Perhaps it holds eyewitness clues to what happened.
When I first came into the cave, the sand was as high as this level, and I had to crawl in because the sand had covered the whole area. Well, this wind-blown sand cannot form when the desert is green.
Buried in the sand was the first clue, some perfectly preserved animal droppings.
So these animal droppings don't only tell us about the climate at the time, but they also are excellent materials for radiocarbon dating, which allow us to date the final event of the drying of Sahara.
These goat droppings, covered in sand, reveal a time when a farming community was overwhelmed by desert. Hidden in the back of the cave is a clue that confirms people sought shelter here.
The cave has a very interesting feature, which is the prints of hands. So this is excellent evidence of the people that lived here.
The next clue suggests that around them, the Sahara was beginning its relentless transformation into desert.
Well, here we see a very interesting drawing with these long lines. This represents a cloud with rain coming down. Rain was becoming very scarce at that time, and they would have used this cave to pray for rain.
But with the monsoon now several thousand miles south, their prayers could not be answered.
Well, this cave must have been a very important sacred place for these people at a time when things were getting really bad.
Eventually, despite these rituals, the force of this change was so great, they had no choice but to leave.
Here in this cave we have the sand and we have the handprints, which is the last message left by the Saharan population.
The story of this cave started with a tilt in the Earth's axis that stopped the rain falling on the Sahara. What must have seemed like a never-ending drought would, in just 200 years, turn a gentle, fertile region the size of the United States into a brutal, searing wilderness, the wasteland we see today. This would be the biggest environmental upheaval of the last 10,000 years. Those that could must have migrated east to their closest source of water, the valley of the Nile, a beacon of green in the vast desert. This exodus had a surprising outcome. The death of one culture 5,500 years ago would lead to the birth of one of the most advanced civilizations on the planet.
It was a drying of the desert that led to this great civilization. People came from different places in the desert, established their villages, and within a very short time, they began to have the basic ingredients for the rise of Egyptian civilization. So climate change, in this particular case, stimulated one of the most spectacular events in world history.
The investigation into how quickly the Sahara returns to desert has uncovered two striking clues. Ostrich eggshell beads show people and animals inhabited a green Sahara just 7,000 years ago. Ocean sediments show that the Sahara returned to desert at breakneck pace in just 200 years. The next wobble in the Earth's axis is set for 15,000 years from now. Only then will the Sahara turn lush and green again. But now, modern technology is finding ways to speed up that process. The investigation into the Sahara Desert's eventful past now moves to the last 100 years. In 1956, French prospectors discovered vast reserves of oil in the Sahara. This triggered an oil rush that led to drilling across the desert. Then, they struck something unexpected under the sand: huge quantities of fresh water. It seemed the Sahara had another secret to reveal.
So this is a classic pumped well drilled for irrigating the fields, and the water is actually pretty hot, which means it's coming up from a considerable depth.
The deeper the well, the hotter the water. Water from wells in the Sahara can reach up to 150 degrees Fahrenheit. Such a high temperature means the pump is drawing water from far enough underground to be warmed by the Earth's internal heat.
So pumps like these can bring up water from 3/4 of a mile underground or even deeper.
With no rain for years at a time, this water must be coming from somewhere. Smith spots another clue.
Actually, when I look at the surroundings of the well, I can see some orangish-red iron staining.
This is hematite, a mineral that is typically found in water that's been underground for a long time. Combined with the temperature, this points to some kind of deep reservoir. Scientists say that, astonishingly, great quantities of water lie under much of the Sahara. The key is in the sandstone. Sandstone is made from layers of sand compacted into rock over millions of years.
So what's really incredible about sandstone like this is just how good it is at holding water. And that's because there's a lot of pore spaces between the sand grains that are actually really big. If I pour some water on this rock, just like would have happened when it rained over the Sahara, it soaks right in.
Scientists now know that every 20,000 years, a wobble in the Earth's orbit shifts the monsoon north, so rain pours down onto the desert.
Much of that rain that fell over the Sahara is now stored underground.
It's called the Nubian Sandstone Aquifer, and like a giant subterranean sponge, it sits below Egypt, Libya, and Sudan.
Though there's nothing but sand and rock on the surface, under the ground beneath my feet is as much water as there is in the Great Lakes.
The presence of a reservoir, even one deep underground, is surprising, given the Sahara's searingly hot temperatures. In 1922, in neighboring Libya, the mercury touched 136 degrees, a record still not beaten. But ironically, the water is protected by the desert itself. Layers of clay encase the sandstone. The clay keeps out the harsh sun. It also acts as a sealant, trapping the water within the rocks and creating pressure. Fault lines in this clay are the source of the desert's famous oases.
So this is a natural spring where water is coming up from the Nubian aquifer under its own pressure. This is actually fossil water. It's been dated to be up to 1 million years old.
This reserve of water is a legacy of the Sahara's lush green past, the remains of its giant lakes and rivers. And this is just one aquifer. Scientists are now using ground-penetrating radar to locate and map other aquifers across the Sahara. They hold the promise of even more fresh water. This new technology offers hope that the desert may once more turn green, reclaimed for agriculture and farming. If all goes to plan, eventually there will be 200 wells here. But drilling could prove a short-term solution.
This is fossil groundwater. It's not being renewed. So eventually, you're going to run out. Water that supported prehistoric occupants in the area and accumulated over 1 million years is potentially going to be gone in less than 100.
Once the underground water dries up, the desert will have to wait another 15,000 years before once more the Earth's wobble turns it green again. The mystery of what created and changed the Sahara Desert has revealed a turbulent past. Whale bones in the desert show that 40 million years ago, the Sahara was a seabed. Deep ocean cores containing windblown sand reveal the date it dried up, 3 million years ago. Freshwater shells show that 90,000 years ago, a wobble in the Earth's axis created giant lakes and rivers and turned the Sahara green every 20,000 years. Ostrich eggshell beads indicate that just 7,000 years ago, the Sahara enjoyed its final burst of life before returning to desert. The secrets of the Sahara have finally been revealed. This desert is not a static wasteland. It's dynamic and full of life, capable of blossoming into lush green terrain. This vast, majestic land continues to shift, change, and evolve, much like the Earth itself.